Okay, we have to talk about some special cases. Mostly, we're just going to see this in the D block and the F block. And all of our special cases are built around this idea that a half-filled and or a completely filled subshell has a unique stability. So when I talk about shells, I'm talking about principal quantum numbers. When I'm saying subshell, I mean the letter. So this, if it's a 4D or a 3D, that is a subshell within the n equals 3 shell. So because of this half-filled or completely filled, we end up with some exceptions to how the electrons go into orbitals when we're in the D block and when we're in the F block. The great news is that most of these are published, and I am only going to ask you to know a few exceptions. So I think I'm asking you to know 6 that will be pretty, there will be a pattern to how you can spot them to help you out. So I would like you to be able to do D block configurations with the exceptions that I've got highlighted in pink. We're going to talk about why those are exceptions and what you should know. With the caveat that, like, as we're going to look at, I've got the electron configurations for all of the transition metals here. I mean, well, basically the things across rows 4, 5, and 6. There are occasional other exceptions that I'm not asking you to know. So let's just go across row 4 and look at what we have. So potassium ends in 4s1, calcium ends in 4s2. Those are in my S block. Not super surprising. Then I get to scandium, which, remember, this is where the d orbitals start. So I have filled 4s2, and then I put my next electron in 3d. So I have 4s2, 3d1. Titanium, adding another electron, it ends in 4s2, 3d2. Vanadium is 4s2, 3d3. Right, I've added another electron. Chromium is 4s1, 3d5. So instead of being 4s2, 3d4, one of the electrons that should go in S went into D. So now my D subshell is half filled. So I can take advantage of that unique stability. For manganese, we go back to just what you would expect. It's 4s2, 3d5. Iron is 4s2, 3d6. Cobalt is 4s2, 3d7. Nickel is 4s2, 3d8. But then we get to copper, and instead of being 4s2, 3d9, it's 4s1, 3d10. So we're getting more stability out of having a completely filled D subshell as opposed to having the S completely filled with just the 2 electrons and having an almost completely filled D shell. And then zinc goes back to the expectation of 4s2, 3d10. So chromium and copper in that top row of transition metals, those are my exceptions, where instead of having 2 electrons in the 4s, I have 1 electron in the 4s and 1 more electron than I would expect in the 3d, which gives me either a half-filled subshell or a completely filled subshell. Row 5, I'm not going to read every single one because I know that you can look at these. For molybdenum, which is directly underneath chromium, has the same pattern, 5s1, 45 to get half filled. Keep going, silver, which is directly under copper, 5s1, 4010, same pattern. So chromium, copper, molybdenum, silver. Make it half filled or make it completely filled. Now, I have skipped over things that you might be seeing as exceptions, right? Like niobium, we didn't look at. It says 5s1, 44. It's an exception, but it doesn't fit our pattern. And there are just some other more complicated things going on related to size and so many other things. That's why I'm not asking you to know that as an exception. I mean, we end up, right, technetium, ruthenium, rhodium, palladium ends up being, they're just doing different things. So you don't have to know those. So I either won't ask you about those, or if you were to give me the expected configuration, that would be fine. In the third row, I have gold. I'm going to skip all the way over. So take a look at gold. It's got 6s1 and 5d10, which follows the pattern, but also it has a 4f14 because when I go across row 6, I fill the S block, and then that's where I hit the lanthanides and actinides. So I have to jump out and fill up my F block, which you'll notice the lanthanides and actinides are 14 columns wide. Then I go back to filling up my D electrons. All right, that's gold. The last one that's highlighted, tungsten, is not an exception. So the columns that I want you to know are chromium, molybdenum, tungsten, copper, silver, gold, where 5 of them follow the exceptions of having one S electron, either a half-filled or a completely filled D subshell, except tungsten, which does 6s2, 4f14, 5d4.